Hi everyone and welcome back. We are now in week 11, so really in the final stretch of the course here, and today's topic is going to be how to compare means from two samples with t-tests. The good news is that this is pretty similar to what we were doing last week, so it won't be a whole lot of new information to process, and because of that, it should be a relatively short lecture. So let's talk a little bit about testing differences between means. What I mean by this is that you can use a t-test similar to the one we did last week to answer questions like, do male police officers use more force than female police officers? Do black defendants get harsher sentences than white defendants in court? Do prisons with drug treatment programs have fewer assaults than prisons without drug treatment programs? So what you should see all of these have in common is that we're comparing two groups to each other. And specifically, we're looking to see whether both groups have, the same level of some variable or different levels of some variable. So that's what we can do with a t-test that looks at differences in means. So to go through one of these t-tests for two means, I'm going to introduce just two new things on this slide, which luckily are close cousins to things that we did last week. The first one is just going to be how to write hypotheses for two means rather than one. So last week we were looking at whether one sample mean was likely to have come to a population where there was some value for the population mean. In looking at two means, we're looking to see whether two different samples are coming from a population that have the same mean as each other. And I'm going to go through an example of how to write a hypothesis for this using the male and female's use of force example. That was the first one on that last slide. So how we write hypotheses here is we have our null and alternative hypotheses like we did for the one mean t-test. But instead of saying that one mean in the population is equal to some number, what we're saying is that the means for our two populations that we're looking at are equal to each other. So our null hypothesis there, HO, would be that the mean, level of use of force for male police officers is the same or equal to the mean level of force used by female police officers. So we have mu there, which refers to our population mean, and with each of those we're saying that would be the population mean for men and the population mean for women. So in our null hypothesis, we're saying they are equal to each other. And so we're going to be using the hypothesis test to try to get evidence for whether, based on some samples we have, it's possible that our two sample means came from populations that have means that are equal to each other. The alternative hypothesis, or HA, is the same thing it was before, meaning that it's essentially the opposite of our null hypothesis. And it's what would be true if our null hypothesis is not true. So if the mean level of force used by male police officers is not the same as the mean level of force used by female police officers, we would say that the mean for male police officers is not equal to the mean for female police officers. So that's how we'll be writing hypotheses for the two mean t-test. Another way of writing these hypotheses, and this will come into play when I talk about the sampling distribution we're going to use in just a second, would be to subtract from each side of the equation to make it look like this. So looking at that null hypothesis there, the mean for men minus the mean for women is equal to 0. That's the exact same equation as the mean for men is equal to the mean for women. We've just used algebra to move the mean for women over to the left side of the equation. So we're saying the exact same thing there. And they have to be equal to each other for them to be 0 when you subtract one from the other. For the alternative hypothesis, it's the same idea. We're just saying that if you subtract one from the other, it's not going to be equal to 0. In other words, they have to have different values in order to not be equal to 0 when you subtract them. So same hypotheses, just written a little bit different. We just use some algebra to say, instead of saying that they're equal to each other, we're saying if you subtract one from the other, it's going to be equal to 0. And the reason that we can write it out this way is that the sampling distribution we're going to use to test for a difference in means is going to be based on the difference between those means. So difference meaning subtraction. So our hypotheses are going to be written as differences so that we can look at the difference between the means in our sampling distribution. And what a sampling distribution for differences between means shows you are possible differences between sample means and the probability of getting each one. And it will be the shape of a t-distribution. But before I go any further, I'm going to jump over to the document camera and I'm going to show an example of a sampling distribution for differences in means and also how you would plot sort of different sample means and their differences on it.